My name is Hideki Hirori. The title of my talk is Making Invisible Worlds Visible. Firstly, I would like to show you a nice picture of the mountain of Daisen. This summer, I visited the Daisen, and this is me. I'm very dark, but at that time, the sky is very blue. The bright sunlight was coming, so thanks to the sunlight, we could enjoy the very nice view of the nature. And yeah, of course, during the daytime, thanks to the sunlight, we could see the very nice view of the mountain and the nature. But under the darkness of night, our naked eye doesn't work, almost doesn't work. However, there is still a small light, actually infrared light. Actually, some snakes can hunt or catch animals by detecting infrared radiation or infrared light. And not only the infrared light, also microwave light is coming from the space, and it's called as a cosmic background radiation, and it tells us the history of the universe. So the question is, what is the difference between the visible light and the infrared light and the microwave light? It's just only wavelengths. This is a chart of the light with different wavelengths. Here is the visible light, and here infrared light, here microwave light. From left side to right side, the wavelengths becomes shorter and shorter. And our naked eye can detect the wavelengths of 380 nanometer to 700 nanometer. And the infrared wavelength is a little bit longer than the visible light. And the microwave wavelength is much, much longer than the visible light and the infrared light. Actually, it's from 1 millimeter to 10 centimeter. So I would say that we are surrounded by the many kinds of natural lights, and it's very convenient to see and to get information from the objects. Yeah, for us, we can see the object by sunlight, and the microwave gives us the history of the universe. The infrared light is important for the snakes. So the humankind has started to develop or invented the technology to generate artificial lights, and it allows the human life richer and richer and more convenient. As you know, Dr. Röntgen invented technology to generate X-rays, and it allows us to see our bones in our body. And Thomas Edison and many researchers developed the electric bulbs or LEDs. It's very convenient for the illumination, and it's also used in the remote controller of electric devices in your house. And also microwave is very convenient to warm up your cold food from your refrigerator. And radio frequency wave is very cool technology. Actually, it allows us to communicate to each other regardless of our physical distances. So I would emphasize from these figures the good and the new and the cool technology had come to our ordinary life after developing new lights. So, but still, yeah, you can see here, there is a missing region. We call here terahertz region. I will explain why we call this region terahertz and why it's so important. Yeah, I explained the lights with different wavelengths, and the typical wavelength of terahertz frequency region is 0.3 millimeter. And the light can be also characterized by the frequency, and we can convert the wavelengths to frequency by using very simple equation, just by dividing the speed of light by wavelength lambda. In this case, the frequency of this terahertz light is 1,0,0,0,0,0, many zero, but actually there are 12 zeros, and 10 to 12 is expressed as a tera. So the frequency is 1 terahertz. So we call this region terahertz light or terahertz wave. So why it is so important? Because there are many potential applications. For example, you can see one guy, and it's taken in visible light. And if you see this guy with terahertz light, you can find that this guy has knife hidden by his newspaper. And this means terahertz is highly transparent for clothes and paper, and also it's not transparent for metal and water. In this case, knife and a human body. And also, the photon energy of terahertz is much, much smaller than the X-ray, so it's much more safer light compared with X-ray security check system. And also, it has a potential application to drug test. You can see there are 3 kinds of chemicals packed in the plastic bag. And the left one is codeine. It's used in the normal medicine. And the right one is sucrose. It's like a sugar. So both are not illegal one. But the center one, it's a cocaine. Yeah, it's illegal chemicals. But you cannot distinguish between them in visible region. But if you see these chemicals with terahertz light, you can distinguish chemicals. Because these chemicals has different absorption line in terahertz frequency region. So when you shine the terahertz light onto the chemicals, the intensity of reflected terahertz light or transmitted light is different for each other. So we can distinguish these chemicals as a difference of intensity of terahertz light. So I would say the terahertz frequency region is a fingerprint region of molecules. And the other application is medical imaging. This is a cancer tissue of a human skin, and taken in the visible frequency region. And solid black line indicates the cancer region, and dashed line indicates the normal region, not a cancer. And it's hard to distinguish between these 2 regions. But in by using terahertz light, you can distinguish between these 2 regions, because the terahertz light is strongly absorbed by water molecules, and the cancer region has less water contents compared with normal region. So when you shine the terahertz light onto this tissue, and the transmitted terahertz light in the cancer region is higher. So yeah, we can. So also we can distinguish these 2 regions as a difference of transmitted intensity of terahertz light. So to make these imaging applications in reality, the important point or problem is the speed of imaging. If you use a weaker terahertz power generator, the imaging speed is very, very slow, like this. So if you use a much stronger terahertz generator, maybe the imaging speed becomes much, much faster. So to make the terahertz imaging system in real application, the stronger terahertz generator is required. So to do this, there are many researchers in all over the world developed the terahertz generation techniques. And this graph is showing the terahertz power developed by the other research group in all over the world as a function of the year. Yeah, and MIT and University of Tokyo developed a very nice terahertz source. But there is a difficulty to overcome the field strength of 1 megavolt per centimeter of terahertz power. But 2011, we could overcome the difficulty to generate the terahertz pulse with 1 megavolt per centimeter. Actually, it's the world's strongest terahertz source. And before going to my setup, I would explain the different devices to generate the terahertz wave. And you are very familiar with, actually I'm using the laser pointer. And if you break down this laser pointer, you can see like this. The important point is just 3 components. One is, firstly, the infrared laser is coming from the semiconductor devices, and there is a crystal. And the infrared laser is going through the crystal. The wavelength of infrared laser is converted to green laser. So, and the actual setup, or my setup is, there are many optics and mirrors and lenses, but the principle is very similar with the laser pointer. Now we are using a lithium niobate as a crystal, and we are shining laser beam. Its wavelength is 800 nanometer onto the crystal, and especially we optimized the focusing condition of laser beam. We could generate very strong terahertz light, and we can convert the wavelength 800 nanometer to 300 micrometer. And then, we have a very strong terahertz light. So we apply the strong terahertz light to develop a microscope to see a living cell. Yeah, actually, this observing a living cell is the ultimate goal. And actually, by using our high-power terahertz source, we could develop the world's fastest terahertz microscope with a very high spatial resolution. It's a collaborational work with Olympus. And I hope, and I imagine, and the terahertz power is getting higher and higher. We may be able to take a larger image of our picture, and also with a higher speed. And I hope in future, it can be used in the surgery space. And also the important point is by using a terahertz light, we can detect the cancer or some diseases area. It cannot be detected by naked eye, but hopefully terahertz can detect these kind of cancer region and help the surgery a lot. Okay, thank you for your kind introduction. Sorry. Thank you for your kind attention.